Let me start with a couple of personal remarks about Pat. We met, I think, for the first time in about 1955, and it was not the greatest meeting. One of the consequences of that meeting was that the little book, Individual Choice Behavior, came out with a bright red cover because it got to be called the Red Menace. But there's a story behind it, but I won't go into details. Then at that point, we got very interested in measurement issues, and when Bushwiner and I did the handbook of mathematical psychology, we got Pat to do the first chapter on basic measurement theory, and then Pat and I later, I think it was volume 3, did a chapter on utility and subjective probability. I probably shouldn't waste any time talking more about that. I'll get down to my talk, the title of which is there. Hölder's theorem was developed in 1901 as a formalization of extensive measurement in physical sciences. And it stemmed from work that Helmholtz and others had done, but Hölder was a mathematician and he really formalized it. And he showed that if you had certain axioms, which I won't detail, and you mapped into the additive reals, the structure had a representation that was simply additive. And that theorem was very well known and has been used fairly extensively. But he also basically had to consider multiplicative conjoint representation, which was concerned that mass was volume and times density. So you had, in addition to addition running around, you had multiplication. So you could ask the question, why did he map just into the additive reals? Why not into the full reals? And I think people presumed the answer was that there wouldn't be any difference. The truth of the matter is there is a difference. And you get this particular equation where you have the additive term, but then you have a multiplicative term with a constant that's either -1, +1, or 0. Now, in the physical case, he had distribution conditions that, let me say, we call this representation P additive, meaning P for polynomial, because it had been shown in the functional equation literature that the only polynomial that you could map into the additive representation was this particular polynomial. And the distribution laws that existed in the case of mass between extensive structure and the conjoint structure to make them come out with the same mass measurement. Those laws ruled out anything except the delta equals 0 case. So for physics, the oversight meant nothing. I will argue that for psychology, this was quite important, this oversight. And that's what I want to try to describe to you briefly. I developed a theory in the Psych Review in 2004 about basically the binary receptors, such as the eyes, the ears, the arms, independent organs that work as a team in some sense. And the theory then concerns really coding how this binary structure works. And the trick that I used was to say, okay, you put intensity X in, say, the left ear, and intensity U in the right ear, and then you match that to a Z where you put the same intensity in both ears, and define the operation X circle plus U to be equal to Z. And then you really then try to axiomatize the structure so you find out how circle plus works. The second kind of primitive in this work it is you get the experimenter to present a signal and a number and ask the respondent to say, well, and there's also a reference signal that I call rho, which is either experimentally given or is generated by the respondent. And you could think of this as an operator where the respondent is producing Y as the signal that has the subjective impression that the interval from rho to Y is P times the signal subjective intensity from rho to X. This is, if you take set rho equals 0, this is S.S. Stevens' method of magnitude production. It's a generalization of that. Then you have to worry about linking the two operations you have running around, and I formulated some axioms about that. And there are two linking properties, in some sense, are pretty analogous to the distribution properties of physics. And this means that we have a psychophysical function for both the matching and for the production. And this led to the representation that's shown here, where you have the P additive 1 over the circle plus. You have constraint on circle plus, it's in the middle equation. And then you have the weighting function on the number P, such that the subjective differences, the ratio of the subjective differences is constrained by WP. And that was the representation I arrived at. And I thought I had shown in the 2004 paper that the delta had to be 0. And that turned out to be wrong. I made a mistake. And that was pointed out to me by CTMG, and I'll come back to that in a minute. Working with Ragnar Stein-Grimson, we did a series of experiments in loudness, supporting the various axioms of the theory, and he has been working in vision, both in brightness and perceived contrast, again with very good support for these axioms. By the way, unlike most psychologists, we focus entirely on individual respondents. There are enough individual differences running around in this work that this averaging that is commonly done is nonsense. And I wish psychologists would get this through their head, that they simply are dealing with people who differ in various ways, parametrically and functionally. And the averaging over subjects is just a terrible mistake. We were able to show a behavioral invariance that I won't bother to state that led to a power function, the sort of thing that Smitty-Stevens was pressing for a quarter of a century or more. Stevens felt that this power function representation applied to all so-called prophetic dimensions, the subjective intensity dimensions. I'm going to be arguing in a second that's not quite true. And one of the things that you find if you look back on that literature, one is that it was average subjects, and another is you draw a nice smooth curve through a set of data points, and you kind of convince a person that there's one form rather than another, and that sometimes can be misleading. Some familiar properties of operators we looked at. Commutativity was one, and we rejected that for all the binary domains we've looked at. We have not looked at weightlifting, so presumably that would be. Associativity we haven't looked at, and we'll see in a minute why not. And the last property is bisymmetry, which is this one here, and essentially says you can interchange the inner ones and it doesn't affect the perception. And we've sustained that in all the things we've looked at. Now, it turns out that you can prove the following, it's in the site review in press, that with delta equals 0, of course, bisymmetry is satisfied. For delta not equal to 0, bisymmetry is satisfied if and only if commutativity is satisfied. But the data are saying yes to bisymmetry and no to commutativity. So that strongly suggests that you have to conclude delta equals 0. And I've corrected that claim of mine that G pointed out. And in this context, if bisymmetry holds, associativity cannot hold. So we haven't run the associativity experiment, but I kind of think it's a foregone conclusion what would happen. Now, many subjective intensity senses are not binary; they're unit. And I'm thinking of things like money, odor,